Today, we are going to be solving question on system of unbalanced forces, the concept of vector addition. Question 1. A man walks 1 kilometer due east. Let's say this is the starting point of the man. The man walks due east, 1 kilometer due east. When he got here, then 1 kilometer due north. North is upward. 1 kilometer due north. What is displacement? You are looking for displacement. Displacement is the shorter distance between the start point and the end point. So this is the displacement along this direction. So let's call it x. So definitely s squared equals to 1 squared plus 1 squared, which equals to 2. S squared is 2, then x is root 2 kilometer. What about the direction? This is northeast. At what angle to the north? We have to get this angle. Let's call it alpha. So tan alpha is opposite over adjacent, 1 over 1. So if tan alpha is 1, alpha is 45 degrees, because 45 degrees, tan 45 is 1. So from here, it means the displacement is root 2 kilometer, then the direction is not 45 degree east, and that's option C. Now, question 2, before that, we should know the 4 cardinal points that this is north, south, east, west. So, an aircraft traveled from Calabar to Kano as follows. It flew first to Ilorin, covering a distance of 300 kilometers, 30 west of north. So this is north, this is west. So something like this, up like this. So west of north. And then when it got here, it flew 400 kilometers, 60 degrees east of north. This is north, this is east, 60 east of north. So this is 60. So there is 60 degrees. This first one here is 30 degrees, 300 kilometers. And this one is 400 kilometers. So the question is, what is the resultant displacement? It started from here. So, sorry for this. It started from here and it ended up somewhere here. So we are looking for the displacement. Let's call this x. Now look at this. If this is 30 degrees, then this one will be 60. Because total angle is 90 degrees. 60. This also be 60. Because they are alternate. So it means the whole of this angle is 120 degrees. So we can redraw this triangle as something like this. We have a triangle. Two sides are known. 300, 400. We are looking for this side. Let's call it x. And this angle is 120. So definitely we'll be using cosine rule. So applying cosine rule, s squared equals to 300 squared plus 400 squared minus twice their product. That's 300, 400. Cos 120 degrees, and this should give us 90000. This is 160000. Then cos 120 is same thing as minus cos 60, and cos 60 is half. So minus times minus become plus. Half of 2, 1. Then 3 times 4, 12. 0000. So when we add everything together, if we take the square root of both sides, then you get the value of x. Let's move to question 3. In this question 3, we are looking for distance. A man walks 8 kilometers due north. 8 kilometers due north. In the direction, and then 5 kilometers in the direction of 60 degrees east of north. So north is up, east is here. This is east of north. So 60 degrees east of north. 5 kilometers. So we now ask, find the distance from a starting point. So it started from here, it ends up here. This is displacement. But we are told to look for distance. What distance? We just add. So distance is a scalar quantity. We don't need to consider the direction. That's 8 plus 5. That's 13 kilometers. That's option C. I don't mean that we are told to look for displacement. We are going to apply cosine rule to get the value of x here. Now, question 4. A lorry travels 10 kilometers northward Then 4 kilometers due east. So this is 10 kilometers north, 10 km. Then 4 kilometers due east, this is due east. Then when you get here, 6 kilometers eastward, 6 kilometers eastward, and 4 kilometers westward, 4 kilometers westward, 4 kilometers westward. So what is the total displacement? The body starts from here, move here like this, like this, like this, and ends up here. So this is the displacement. If from here to here is 10 and this one is 6. So when we subtract this 6 from this whole 10, we get this to be 4 kilometers. So it's as though the body started from here and moves here. From here to here, that's 4 kilometers due north. That is option B. Question 5. A man moves 20 meters northward, up, that's 20 meters. Then 12 meters east. So this is 20 meters. Then 12 meters eastward. East and 15 meters due south. 15 meters due south. 15 meters due south. Is displacement from the starting point is the man started from here, ends up here. So this is a displacement x. So if we join this together, definitely this is 90 degrees. If this is 12, this is also 12. From here to here is 20. From here to here, which same thing as here is 15. So when we move 15 from 20, we get 5. So we are looking for x. This is a right angle triangle. So x is the hypotenuse. Hypotenuse square equals to the opposite square plus the adjacent square. If you finish it, you should get your x to be 13 meters. That's option A. So for this question, a body of mass 5 grams, you are given the mass of the body to be kilograms. Initially at rest U is 0. Acted upon by two mutually perpendicular forces, 12 up, 5 meeting this way. Shown here. If the particle moves in OA, that is the resultant. Calculate the acceleration. We know that F equals to ma, then A equals to F over m. We are given the mass to be 5 kilograms, so we need to get the resultant force. And this is the resultant force, Fr. If this is 12, this is also 12, 90 degrees. So if you apply Pythagoras theorem, Fr squared equals to 5 squared plus 12 squared, then Fr equals to 13, Pythagoras triple. So our A equals to 13 over 5. And the answer should be 2.6, option C. Question 7 is similar to question 6. A block of mass 2 kilograms, you are given the mass to be 2 kilograms, resting on a smooth horizontal plane, is acted upon simultaneously by two forces. 10 Newton due north and 10 Newton due east simultaneously. So definitely this will be the resultant here. So if this is 10, this is also 10. So this is our resultant force Fr, which you can get using Pythagoras theorem. Fr squared equals to 10 squared plus 10 squared. So Fr squared equals to 200. So our Fr equals to square root of 200, which is going to be 10 root 2 Newton. So but we are looking for the magnitude of the acceleration. So A equals to F over m, which is 10 root 2. The m given is 2. That's 5 root 2 meter per second squared. In decimal, it's going to be 7.07. 7.07 meter per second squared. So the closest is option B. Question 8. Two forces whose resultant is 100 Newton are at right angles to each other. So let's suppose these are the two forces. This one and this one at 90 to each other. This is the resultant 100 Newton. If one of them makes 30 degrees to the resultant, so let's say this F1, this F makes 30 degrees to this resultant. Determine its magnitude. You're looking for F. This is opposite. So this is adjacent hypotenuse. That's cos. Cos 30 is the adjacent F1 over 100. So here F1 equals to 100 cos 30. So cos 30 is 0.866. 0.8660. From here, our F1 equals to 86.6 Newton. That is option D. Oh, sorry, I think that should be 8.66 because here we have 0.086. Wait, let me confirm that. Sorry, it's correct. The magnitude of the resultant of two mutually perpendicular forces F1 and F2 is 13. If the magnitude of F1 is 9, the magnitude of the resultant of two mutually perpendicular forces, say F1 and F2, is this. Meaning, when we have two perpendicular forces, I already told you that the resultant force is F1 squared plus F2 squared, square root of everything. Or I can just write it this way. So in this case, we are given the resultant to be 13. So 13 squared equals to F1 and F2. So if F1 is 5, we are looking for F2. So 13, 5, 12 are Pythagorean triple. So definitely the answer is 12. We can still do it. This 169 equals to 25 plus F2 squared. So if we subtract 25 from both sides, we have 144 equals to F2 squared. Squared both sides, then we get F2 to be 12 Newton. That is option C. For question 10, two forces each of 10 Newton act on a body, one towards the north and the other towards the east. So one is north, 10 Newton. The second one is east, 10 Newton also. So the resultant will be this. That's northeast. So when we check the option, D is east of north. So our answer is either A or D. So let's just look for the magnitude. So if you have two forces and they're both 10, 10, the resultant is 10 squared plus 10 squared, which is going to be root 200 in short form. If you simplify, that's 2 root 10. Sorry, it's 10 root 2 rather. That's option A. So the answer is option A. So in this question, the diagram shows forces 4 Newton, 6 Newton, 10 Newton, and 8 Newton acting at point O in the directions indicated. The net horizontal forces or force is. So these 4 and this 10, they are horizontal forces. But this 8 is inclined. For every inclined force, they have two components. The vertical component and the horizontal component. So this 8, along this, it is going to have horizontal component, which is going to be 8 cos 30. And it will act this way. This 6 also will have horizontal component, which acts here also. This is on vertical, horizontal will act here, which is also 6 cos 30. So in this case, all these three, they are in the same direction, and they are all horizontal. This is the opposite direction. So therefore, the net horizontal force will be the sum of all these three minus this 4 Newton. So that will be 8 cos 30 plus 10 plus 6 cos 30. That's all the force towards the right, east, minus 4 Newton, because they're in opposite direction. So this should give us 4 root 3 plus 10 plus 3 root 3 minus 4. 4 root 3 plus 3 root 3 is 7 root 3. 10 minus 4 should be 6. And the answer here will be 18.12 Newton. And not in the option. So definitely there is something wrong with this question. Suppose this angle here and these angles are 60, 60. So that will be 8 cos 60, which is going to give us 4. And this one will be 6 cos 60, which is also going to be 3. So 4 plus 10 plus 3 is 17, minus 4, that will be 13. So that's if this angle is 30 degrees. So in this case, no correct option. Now in this question, we have to look for the resultant force of these 4 forces. So the best is to look for the sum of all the force along the horizontal. This 3 is along the horizontal. This 10 to the horizontal will be 10 cos 30. And this 6 along the horizontal will act here. That will be minus 6 cos 60. This 3 with 3 will have no effect along the horizontal because it's a vertical force. So if you look for the effects of all the force along y, so this 3 will have no effect. But this 10 along y, it will be up. That's 10 sine 30. Oh, there's a mistake here. This angle is meant to be to the horizontal. So if you are given the vertical angle, you have to use 30 degrees, the horizontal angle. If you want to use cos all through for the horizontal. So this one will not be cos 60, it will be cos 30. So this one is 10 sine 30. This 3 root 3 is along the vertical positive side. Then this 6 will have its own component along the horizontal here, which we've done here before. Along the vertical will be down, which is negative. Minus 6 sine 30. And from here we'll be having 3. 10 cos 30 should be 5 root 3. Minus, this should be 3 root 3. So that will be 3 plus 2 root 3. For the vertical, sin 30 is half, so this is 5 plus 3 root 3 minus 3. That will be 2 plus 3 root 3. Sorry, I think there's a mistake here. Cos 30 is root 3 over 2, so this should be 3 root 3. Oh, sorry, I think we've done that here already. 3 root 3. It was okay. 5 minus 3 is still 2 root 3. So it means all these forces has been reduced into two, the horizontal and the vertical. So the resultant force, in this case, since they are both perpendicular, is the summation of all the force along s squared, along y all squared. When we check the previous note, it is there. So when we insert the values, for x is 3 plus 2 root 3 all squared, plus 2 plus 3 root 3 all squared. You get our final answer to be, the exact value should be 9.67, which is approximately 10 Newton. Question 13. A tugboat is traveling from Asaba to Onitsha across the river Niger with resultant velocity of 20 knots. Let's suppose this is river Niger. So the tugboat wants to move from Asaba, let's say this is Asaba, to Onitsha. If the river flows at 12 knots, so this is the river flow. If the boat tends to move this way from Asaba to Onitsha directly, because of this river current, is going to end up somewhere here. So, and we are told that the resultant velocity of the boat is 20 knots. So this is 20. So the direction of the boat velocity relative to the water flow. This is the boat. This is the water flow. So we are looking for this angle theta. So this is the opposite, which are not given. So we have the adjacent and we have the hypotenuse. Adjacent hypotenuse is that's cos. That's 12 over 20. From here, theta is the cos inverse of 12 over 20. That's approximately 53.13 degrees, which is option B. So for this question 14, so we are told that we have a river flowing due south. So let's say this is a river flowing due south. So a boat traveled due east at a speed of 40 meters per second, and this river flows due south at a speed of 30 meters per second. What is the resultant speed of the boat? So definitely this boat wants to flow this way, but the river will push it down. So at the end, it ends up somewhere here. So this is what we are looking for. Let's call it VR. If the river is flowing here 30, it means you can also put it 30 here flowing here. Using Pythagoras theorem, you get VR to be 50 meters per second. VR squared equals to 40 squared plus 40 squared. Pythagoras triple 435, 40, 30, 50. Question 15. A stream flowing at 0.75 meters per second. So let's say the direction of the stream flowing at 0.75 meters per second. And a boat heading perpendicular to the stream landed in the opposite bank. So this is the boat perpendicular to the stream. Landed, it will land somewhere here at the angle of 30 degrees. So it lands here and the angle here is 30 degrees. Calculate the velocity of the boat. So this is the velocity of the boat if the river is not flowing, and this is the velocity of the boat when the river is flowing, which is the resultant velocity. So let's look for the resultant velocity. So this is opposite. So this is the hypotenuse. Adjacent hypotenuse is cos. So cos 30 is the adjacent, which is 0.75, over hypotenuse, which is VR. From here, VR equals to 0.75 over cos 30, and the answer is approximately 0.866 meters per second. The closest is option B. If we are told to look for the resultant velocity of the boat, when this question they calculate the velocity of the boat. So we don't know if it's the velocity of the boat when the river is flowing or still. But since in the question the river is flowing, so this is the resultant. But if it's a still river, the boat will be able to scale through, move this way with the speed VB. Let's try to get VB. In this case, this is opposite, this is adjacent. So we can use tan. So tan 30 is the opposite, which is VB, over adjacent 0.75. So from here, VB is this times this. So when you multiply, you get VB to be 0.433, which is not in the option. So in short, we are looking for the resultant velocity of the boat. Number 16, the resultant of two forces acting on an object is maximum when we know that for every two forces, the general formula according to the parallelogram law of vector is F1 squared plus F2 squared plus 2F1 F2 cos theta. So if the angle is 45 degrees, let's suppose F1 is 10, F2 is 10. So if they're both 10, 10, if theta is 0, that will be 10 squared plus 10 squared, which is let's use one. If you use 180, cos 180 is minus 1, so this one become minus, so FR will be reduced. If you use cos 90 is 0, so we have F1 squared, F2 squared. So if you have 10, 10, that will be 10 squared plus 10 squared. That will be 200. Root 200 is 10 root 2, so which is now up to 20. So but if theta is 0, cos 0 is 1, so everything here at the end becomes F1 plus F2. In that case, the answer will be 10 plus 10, which is 20. So the resultant of two forces is maximum when the angle between them is 0. That is, let's say this is the body on this floor. We have two forces F1 and F2 acting. If they act parallel to each other, the resultant is the addition, and that's the greatest. For every other angle, it will reduce. And the minimum is for it to be 0 if they are equal and they act in opposite direction. So the answer is B. If the angle between two vectors P and Q is 0, it means they are parallel. That's B. I even said it here. Answer here is B. The component of vector X along the direction of vector Y is 0 when they are perpendicular, of course. For example, let's suppose this is a vector and this is another vector perpendicular to each other. So if this is 5 Newton and this is, let's say, 5 Newton also, or let me use 10 Newton in this case. So the effect of this 10 Newton along the horizontal is 0 because it will not project. There is no angle between them. Or in short, because cos 90 is 0. So the answer is D. Number 19. Two forces of magnitude 7 Newton and 3 Newton act at right angle to each other. The angle between the resultant and the 7 Newton is given by, so since they are perpendicular, let this one be the resultant. So these are the two forces, 7 Newton, 3 Newton. So the angle theta between the resultant, this one, and the 7 Newton force is, we are looking for theta. This is opposite, this is adjacent, so we are using tan. Tan theta is the opposite over adjacent. So it means the answer is C. Okay, for question 20. In the diagram, PQ are vectors. Which of the following represent? Option give the correct relationship between the vectors. Now look at it. This Q goes this way, continues with this. So this is QR and this is P. Q started from here and ends up here. So if we add Q and R, it should be equals to P. So the answer is P equals to Q plus R, which is option A. For question 21, which of the following diagram correctly represents W equals to V1 minus V2? Or we can bring V2 here. We can say W plus V2 equals to V1. So meaning, if direction of V1 is W plus V2. So when we come here, let's look for V1. This is V1. So if this is V1, W should go this way, V2 should go this way. So this is wrong. If this is V1, W should go here, V2 should go here. So the answer is B, correct. So because W plus V, same direction, equals to V1. So this is correct. Let's prove that the option C is wrong. So if this is V1, W should go like this, V2 should go like this. Wait to, since option C2 is correct, because here it means V1 equals to, if we go this way, you have to start from here. It means it should be W and V2. This is also wrong. If this is V1, we have to start from here. This should be W and this should be V2. This is also wrong. So the answer is B. In short, if I have, let's say, consider this triangle here. If I move from here to here, then I move from here. So let me call this one F1, F2. So it's as though I started from here and I end up here. So this is the resultant total, FR. So vectorially, FR equals to F1 plus F2. Last question under this. A body on the ground is acted on by a force of 10 Newton at point P. This force 10 Newton at point P as shown. What force is needed to stop the body from moving eastward? The body from moving eastward. First, what is the total force moving eastward? So we have 5 Newton moving eastward. This 10 Newton has two components. The one that tends to move it upward and the one that tends to move it horizontally. The one moving horizontally is 10 cos 60, which is going to be 5 root 3 Newton. So total force moving towards the east is this 5 plus this 5 root 3. That's 5 plus 5 root 3 Newton is one moving it eastward. But the way this angle is drawn is confusing. So I don't know if this 60 is, this cannot be 60. Everything should be 90. So what's this angle? Let me suppose this angle is 60. So if this is 60, so this should be cos 60. And 10 cos 60 should give us 5 Newton. So now we have two forces along the east. This original 5 Newton and the horizontal component of this 10 Newton, which is also 5 Newton. 5 plus 5 is 10. So meaning originally the force, total forces moving the body eastward, total force moving the body eastward is 10 Newton. So to stop the body from moving eastward, we need another force to pull the body in the opposite direction, 10 Newton towards the west. 10 Newton west will cancel out 10 Newton east. So the answer should be, so it's not in the option, I'll put out myself, option E. 10 Newton in westward direction, or 10 Newton westward. Admin, the question says, what is the force needed to stop the body from moving? Then we have to look for the total resultant force. So we are going to consider the sum of all the force along x, sum of all the force along y. We square this, we add it, find their square root. That will give us the resultant force. We'll look for the direction of the resultant force. So if the final answer is, let's say, 5 root 3 Newton, let's say northeast, something like this. This is northeast, 5 root 3 northeast. Then to stop this body from moving, we need another force in the opposite direction. This is southwest. We need 5 Newton southwest direction. But the question says, what force needed to stop the body from moving eastward? So we have to look for total force eastward, which is this 10 Newton. Then what opposite should be 10 Newton westward. Now we've come to the end of system of unbalanced forces. The next question, which is question 23, will be on system of balanced forces.